Hi everyone, in this video we're going to be going through this short reading. So the study guide for this unit is going to be broken up into smaller chunks, and so I'm going to do a short video on each of these chunks. The first one here is we're just going to talk about what we do once we get data. How do we summarize it? So this is all going to be about ways you can try to summarize data. There's going to be one other way that we'll deal with in a separate video and little mini study guide, just because it's got so much to it. But right now, we're trying to understand how to summarize data, and there's two really kind of big situations. The first situation is you're dealing with numbers. So your data is just a collection of numbers. And you could think of some examples here, maybe a collection of heights of people given in inches, or a collection of incomes. So you get a bunch of people, how much money do you make? Those are numbers. So we are very interested, if you do that, on figuring out what the average income, average height, average quiz score, all of those averages are. But really, that's just the middle. So when you're seeing this word average here or here, you really are just thinking, what's the middle? Okay, so that's what we're going for here. So we're trying to get what's the middle of this data set, whichever data set we're looking at. Now, when we're in that situation, we're talking numbers, we are going to have two main ways of doing the middle. So our first way is called the mean. Right here, here's the mean. And there's a way to calculate this given a set of numbers. And the way we do this is first we add up every data point we have. Add them all up. Then we divide by the number of data points we have. Okay, so very quick example. Maybe my data looks like 1, 2, 5, 7. Just a small little example here. How do I do the mean? And we'll do this one by hand, but we'll often do it in Excel, which I'll show you in a separate video. Well, 1 plus 2 plus 5 plus 7. I'm taking each data point into account here, and then I divide by 4 because there's 1, 2, 3, 4 data points. So I would go into my calculator. I would type in 1 plus 2 plus 5 plus 7. That's going to give me 15 divided by 4. And then usually we like writing this as in a decimal form instead of a fraction. If you plug that in your calculator, you're going to get 3.75. So what we're saying there is 3.75 is, in one way of thinking about it, the middle of this data set. Okay? So that's it. That's the mean. It somehow is trying to describe to us the middle, the average of the data values. Okay, and so that's a very important one. We're going to use a good amount. Okay, so a couple notes here. The mean has to use all the data values, okay, and each one is equal in that it's used once and added up. But there is a little kind of caveat here, the second bullet point right here. Even though every data point is used only once, and so it sounds like it kind of counts the same, that's not true, especially when you have very big or very small numbers. Okay, so watch what happens, and this is something, now that you've seen the mean done, try yourself, right? Pause and try. Let me change my data now to this. 1, 2, 5, 50. So here's my new data. So what did I do? I just replaced the 7 with the 50. This now is a number that's much bigger than the others. 7 was bigger than 1, 2, and 5, but not by a lot. 50, much bigger. So let's do the mean here. Okay, let's see what happens. So again, try this on your own. You can pause the video. But here we go. We're going to add them all up. Divide by 4, because again, there's only 4 numbers. So then this is going to give me 58 over 4. which equals, plug that in your calculator, 14.5. Okay. So here's the problem. The mean is supposed to try to help you figure out where the middle is of the data. But 14.5 is much bigger than these three values. So it doesn't really do a very good job kind of taking these points into account when it's trying to find the middle. It's much bigger than 3 out of the 4 data points. And so what happened here is this 50 that we have. We've got this 50 here. This 50 right here is called an outlier. It's a data point that doesn't fit with the rest. Okay, usually in data we draw a lot of pictures too and look at pictures, and our brains are pretty good at patterns, so we're going to try to recognize patterns. And if we have a point of data that does not fit the pattern, it's very big compared to the rest, very small, we are going to call that an outlier. Okay, now outliers can have a pretty big effect on the mean, as we see here. Just changing from a 7 to a 50, right? They were both the biggest number before, okay? But the 50 being so much bigger, it takes the mean and it pulls it up with it. It drags the mean up, and that dragging causes the mean to not really do a good job representing the data anymore. So we've got to be careful of that. This is why when you have data, you should always look at a picture of it first, visually inspect it for outliers, and then you can calculate your means and your medians and all the things that come with it. And it gives you just a better idea how to think about the numbers you're getting, or if it's really even that useful to think about the numbers you're calculating. So that's a problem with the mean. But luckily, we've got the median. The median helps us with this, which is really nice, because it basically just says, oh, you've got an outlier? I don't really care. So how can it do that? Let's do an example. We'll do it down here. We're going to say take the same data from the first example, 1, 2, 5, 7. Okay, so here's what the median does. It says, all right, get your data, order it low to high. You could go high to low, but let's just do low to high, just like I've done, right? Smallest, 1, 2, 5, 7. Now it says, okay, I want you to split this into 2 pieces. And the 2 pieces are going to be, I want you to take half of the data on one side, group it, and half on the other. So watch, I'm going to draw this green line, and I've got 2 data points and 2 data points. So I've split it in half. Okay, and so here's what the median is. And we need to do 2 examples of this because there's 2 scenarios. The median is going to be, okay, well, if you've split it in half and you drew your green line over a blank space. See how I drew this green line over a blank space here? Well, because I did that, the way I do the median is I have to take, let's do a little purple, like purple. I have to take the 2 numbers right here and I average them. Average. 2 plus 5 over 2. That gives me 7 over 2, which is 3.5. So 3.5 is in the middle of these numbers. Okay? So it's hopefully not too terrible to see that does a pretty good job of telling you where the middle is. Just like the mean before, right? The mean with this data was 3.75. They're both really close. Data that has no big outliers kind of all seems to fall together in the same pattern. The mean and the median will be very close, and either of them will be a good way to describe the middle. But watch what happens with my second data set where I made the one little change. So here we go. We're going to try this other data set. So remember, my data set before was 1, 2, 5, 7, but then I made it 1, 2, 5, 50. Okay, so how does the median work? Same thing. 1, 2, write them out, 5, 50. There's 4 of them here, so I need to split this into 2 and 2. So I'm going to do it. So 2 points to the left, 2 to the right, right? Here, here. Okay. So then, what did I say? I said, all right, if you draw your line and you didn't hit a number, you just drew over blank space, then you take these 2 numbers and you average them. Average, which it's the same 2 numbers, right? So the median is 3.5. Well, look at that. Me taking the biggest number before, which was kind of fit the pattern, it was close to the others, replacing it with an outlier, 50 was the outlier, the median doesn't care. It says go for that. I don't care. I'm only going to tell you where the middle should be. So here we see the median doesn't care about a big outlier. It's still going to do its best to try to tell you really where the middle of your data values are. So if you have data and you've got a really big or really small outlier, calculating the median is a good idea to try to figure out where the middle is, where the real true middle is. Okay? If you're looking for an example of like, okay, these are silly numbers, how does this work in, real numbers? Well, these are real numbers, but how does this work in data I might actually see? Think about things like your income. And we're going to do an example of that on the next sheet, just when we're playing with standard deviation, the spread. But you can think about it now. If I've got incomes with a bunch of people, very similar incomes, and I take the mean, it'll do a good job telling me the middle. The median, same. If instead I've got a bunch of people with similar incomes, but one person with a big, big, big income, then that one person, we just saw it, that one person is like the 50 here. They're going to pull the average up, the mean up. And that's bad because then that mean, if I just tell it to you, you're going to think about this group the wrong way. If you don't have the numbers and I tell you the average, you're going to think, well, then people are making more money than they really are. Because to you, average is the middle, right? But because of this outlier, this person who makes a lot more, they pull the average up, and the mean doesn't really do a good job. But if I tell you the median, then you can always be confident that, okay, that really does do a good job kind of telling me where the middle is, okay? Even with a really big outlier income. So you gotta be careful. Someone gives you mean, an average of something. You got to think to yourself, could there have been outliers in that data? Because if there are, maybe the average, the mean is not what I'm going for. Maybe I should be looking at the median instead. Tell me the median, right? Make sure they give you that number too, where you can go find it. So here's another example where you can go look at that similar idea done. Data given and then them calculated, okay? So those are the 2 big ideas. Let me actually show you one other example just because I want to show you how to do it in every single way. So there is one other way that the median can kind of show itself and is calculated slightly differently. And that's this. Let's say your data is, and I'll just kind of write it all out without the commas right now. 1, 4, 7, 10, 11. This is the easy way. So you've got 5 numbers. So what did we say? We want to split things in half. But you might look at this and be like, wait, 5 and a half? Well, I can't really do that, right? If I try to draw a line somewhere so that I have half data points on each side, it's not really going to work. So then our best bet is to just draw the line right here, and at least this way we get 2 things and 2 things. Well, that's it. That's the median. So in this case, when you have an odd number of things, if you draw your line and it hits a number, then the median is just the number you hit. It's so easy. You just write out your numbers and you try to go find the middle. If the middle lands on a number, that's your median. If your middle does not land on a number, you average the 2 numbers that it touches. There you go. That's the median. So hopefully it's not too bad. Practice some of that. Okay, so then there's another situation that can happen here. Those 2 situations were all about data that we have that's numbers, but that is not always the data we have. So we often want to find out information, and that information we get doesn't look like a number, right? So it looks like something like a word. So for example, maybe I'm interested in asking people, what's your favorite ice cream flavor? Okay, right? I could ask you that. What's your favorite ice cream flavor? Well, the answers aren't going to be numbers. They're going to be words. Vanilla, chocolate, stuff like that. I could also ask you a question. So for example, this is also a question, of course, but I could ask you a different question, like if we were near the time to vote, I could ask you, who will you vote for? I could ask you that question, right? And then your answer. Now, the thing is, when you're doing this, you're trying to figure out what you should do. You want to focus on the answer to the question. Your answer might be candidate A or candidate B. Or maybe you would do not sure. That could be a third option. But when you are thinking about the answer to the question and there's options, not numbers, but options, then averaging in terms of a mean or a median, it doesn't make sense, right? Because think about it. What did we do up here? We had to add the numbers together. How do you add candidate A plus candidate B plus candidate B? That doesn't make any sense. So that doesn't work. So we need a different way to try to summarize the data. If I go ask people what your favorite ice cream is, I'm going to end up with a bunch of stuff that looks like vanilla, chocolate, strawberry, vanilla, mint, red bean. I don't know, a bunch of stuff like that. There's no way for me to add those up and divide. It doesn't make sense. So what I do is I calculate the proportion. So right here, the proportion. So what we do is we pick one specific answer. So in this example here, I would want the proportion. Oftentimes you'll just think percent. It's totally fine to replace this word in your head right now with percent or percentage. That's a great way to think about it. So a way to summarize this data here would be to calculate the proportion or percent of people who said candidate A. Right? If I know the percentage of people who said A, I've learned a lot about that group. And it's not too bad. All we do is we count up the number of people who had said candidate A and divide by the total number of people we talked to. That will give us the proportion or percent. There you go. So there's a couple examples down here. We talked to 750 people and 457 of them prefer Cola A over Cola B. So in your head you could think Coke and Pepsi, whatever you want. So how do we get a statistic out of that? We take the 457 people who said Cola A and we divide by the total number, 457 over 750, which, when you plug that in a calculator, gives you 0.61. Now you'll notice in this problem, there's 3 different forms that this is given in, which can be a little bit of a headache sometimes, but we're just going to practice. You're going to get that practice in the computer homework. So the proportion here can be given as just the fraction using the numbers from the data, or the decimal that you get when you plug it in. Usually we just round this to 2 or 3 decimal places, or we can convert this to a percentage. So you'll often see 3 different forms of this, and you're just going to want to practice kind of going back and forth here. The way that I like to think about this is there's 3 ways, right? But they all serve a different purpose. The percentage is how we talk to people, right? Just say some of these out loud. 61% of people prefer Coke. 0.6, the proportion of people who prefer Coke is 0.61. What? that doesn't sound right. So get that out of here. 457 out of 750 people prefer Coke. Like, okay, I guess it's a little better, but not good. So when we're talking to each other, go percent. When you're doing calculations with this, which we'll do some later, go with the decimal. When you're first just trying to set things up to get the decimal, that's when you use the fraction. So the fraction's the setup, the decimal is for calculation, the percentage is for talking. I know, right? Like, what did you're thinking? I got to do different forms for talking to people? Yeah. Right? We want to be able to talk to each other. We should use language that people are using. So just, have it in the back of your mind that you're going to see these in different forms, and all it takes is a calculator to convert here. Okay. All right. So hopefully that's not too terrible, those different forms. Now, what you were going to have to be able to do is try to now use these ideas and apply them to situations. So here's an example. It says, Bob measures the height of all people in a kindergarten class, including the teacher. Tom measures the height of all people in a college history class, including the teacher. Both data sets are recorded in inches. So Bob and Tom just both have two data sets with inches in them, just heights. Which data set do you expect to have the higher mean? So stop here, think about it. Which of the two data sets, the kindergarten class heights or the history class heights, will have the higher mean? So remember, mean here, you can just think in your head, average, and in this case, what are you measuring? Heights. So I think hopefully it wouldn't be too bad to see that the average heights, right, would be higher in the history class. Why? Well, the history class in college is going to have mostly adults in it, most likely, and adults are usually taller than kids in a kindergarten class. So, taller people, that means their heights will be bigger. You're adding up bigger numbers, your average is going to be bigger. Boom. So we don't have the numbers in front of us, but we have to be able to use the ideas, think about them, write down heights that you think, right? If you're stuck with this, just pretend that you know Bob and Tom's numbers and think about them. So if you do that, you'll get Bob has kindergarten kids. Well, you would get things, well, now I'm going to look stupid here because I don't know how tall kids in kindergarten are. But, Tom's going to get people who are like, 60 inches tall, you're 5 foot tall, and then you're like 65, you're 5'5", and maybe you get 70 inches tall. They're adults. Here, though, you're going to be probably, again, I'm going to look ridiculous, in like the 40 inches, and maybe you're like 45 inches. And so these numbers will be smaller than Tom's numbers, okay? So that's what we should be thinking about this. Bigger numbers, bigger average. Smaller numbers, smaller average. Okay, B, what does that say? Suppose I'm looking at one of the data sets. I find that 1 out of 20 equals 5% of the data values are at least 65. Which data set am I looking at? So we got to break this down, right? So again, 65. What does that mean? That refers to being 65 inches tall, which is 5 feet 5 inches. Okay. So what is this saying? It's saying only one person got to 5'5". Everybody else was shorter than that. So what this really is saying is that everybody else, besides the one person, is shorter than 5'5". Everyone else is shorter than that. So think about it. Which data set is going to have a room full of people who are all shorter than 5'5", except for the one person? Well, that's going to be Bob, because Bob has the kindergarten class. And what did we say? These students are shorter. All these students are shorter. So this is the ideas that you can play around, you can think about what the data set should look like, and you can kind of understand them by really thinking about them, okay? So that's what you gotta do with this kind of stuff. You gotta really try to dig in, think about it. It's not just about crunching numbers. It's about thinking about the numbers you get and then could get in any situation. You guys have a ton of experience and knowledge and just understanding of the world that you need to bring into this and not just kind of go about trying to calculate using the formulas or the ideas. You need to always be thinking about what should happen and use the calculations and the numbers you get to either back up what you thought, or if you get something different, maybe you have to change what you were thinking. So you got to engage with this as you're doing it. Okay. Would the mean or the median be higher in Bob's data set? Okay. Well, so Bob, remember, Bob is kindergarten, so just kind of keep reminding yourself that. Bob is the kinder kids. So Bob has the kindergarten kids, right? So he's got a bunch of small values, short heights, and one big height, right? So is the mean or the median going to be the bigger thing here? Well, what happened? What did we say when we had a bunch of data points? And I'll kind of try to think about drawing this in a line. So here are heights. Visual is always a good idea. And so we've got a bunch of kids' heights here. And then what happened? Boom. We've got this one big teacher height. So this is the teacher. And then these are the kids. Now, I'm not drawing this to scale, but this is the idea. We've got the kids all together, and then the teachers one big height. So the median, think about how we did this. We don't need the numbers. You just got to think about it. The median is probably going to be around right here, because if I try to split all my data points in half, it's going to be right around here, because it doesn't matter that this data point's really far to the right. It's still just counted by the median as the biggest one. So this one here would be my median. But what did we see happens with the mean? Remember, the mean wants to get you the middle, but if you've got a big data point here, the mean gets pulled over, right? It gets pulled by the data point, this outlier. So because we know there's an outlier, one big value, we know then that the mean should be bigger than the median. And this is because of the outlier. I don't need to do a single bit of calculation to think through that, know that that's going to happen. This is the type of thing you've got to apply to other situations. Incomes, house prices, heights like we're seeing, ages, anything that we have numbers to describe. You've got to be able to think about this. When could outliers happen? Just by thinking about the scenario. That's got to be in the back of your mind, because then when you see data, like I said before, you need to be thinking, could there be outliers here? How am I going to deal with that? Well, you deal with that by using the median, not the mean. Okay, so hopefully that's not too bad to get through. What you're going to do for just the calculation piece, you're going to go to the computer homework, you're going to do some practice, some proportion practice, mean, median. You can do them by hand. You can do them using Excel, which that'll be in a separate video you'll see to go through Excel. So go check that out, practice, and let me know if you have any questions on this as you're going through it.